My dear students, welcome back to our channel. Students, in this video, I am explaining JNTU Hyderabad MBA third semester subject
Business Analytics.
Important questions, one by one. Let's start with first one. Define data analytics. Data analytics is the process of examining large sets of data to uncover hidden patterns, correlations, trends, and insights that can help organizations or individuals make informed decisions. It involves various techniques like statistical analysis, data mining, machine learning, and predictive modeling to interpret data and solve problems. Example: imagine an e-commerce company that wants to increase sales. They can use data analytics to analyze customer behavior. By examining data such as purchase history, browsing habits, and demographic information, the company may find that a significant portion of their customers are more likely to buy during weekend sales or are interested in particular product categories. Using this data, the company can adjust marketing strategies such as offering special discounts on weekends. They could also tailor product recommendations based on customer preferences, improving the overall shopping experience. In this case, data analytics helped the company to understand customer behavior and optimize their sales strategy. Next important question is the importance of data analytics in an organization. Data analytics plays a crucial role in helping organizations make informed decisions, optimize processes, and improve overall performance. By analyzing large volumes of data, organizations can gain actionable insights that drive better strategies and outcomes. Here's why data analytics is important for organizations. 1. Improved decision-making. Data analytics helps organizations make decisions based on facts and data, rather than intuition or guesswork. With data insights, managers can evaluate options more clearly and choose the most effective path forward. Example: a retail company can use data analytics to determine which products are selling the most in different regions. Based on this analysis, they can adjust inventory levels to ensure popular products are well stocked in each region, increasing sales and minimizing stockouts. 2. Cost reduction. By identifying inefficiencies, data analytics helps organizations optimize their operations and reduce unnecessary costs. By analyzing operations, supply chain, logistics, or even marketing expenditures, organizations can improve resource allocation and cut down on wastage. Example: a manufacturing company uses data analytics to track production line performance. The analysis reveals certain equipment is underperforming and causing delays, so the company invests in upgrades, reducing downtime and production costs. 3. Enhanced customer insights. Organizations can use data analytics to understand customer behavior, preferences, and needs. This allows businesses to tailor their products, services, and marketing efforts to meet customer demands, improving customer satisfaction and loyalty. Example: an online streaming service analyzes viewing habits, searches, and ratings to recommend personalized content to users. This enhances the customer experience, increases engagement, and leads to higher subscription retention rates. 4. Competitive advantage. Data analytics can help organizations stay ahead of competitors by uncovering trends, market shifts, and opportunities that others might not notice. With real-time insights, companies can adapt quickly and maintain an edge. Example: a financial institution uses data analytics to track market trends and assess customer sentiment. This information helps them predict changes in market conditions and adjust investment strategies proactively, staying ahead of competitors. 5. Predictive analytics and future planning. With predictive analytics, organizations can use historical data to forecast future trends and outcomes. This helps in better planning, risk management, and anticipating potential challenges or opportunities. Example: an airline uses data analytics to predict flight delays by analyzing weather patterns, historical flight performance, and other factors. This allows them to proactively manage schedules and inform passengers, improving customer satisfaction. 6. Improved operational efficiency. Data analytics helps streamline operations by identifying bottlenecks, underperformance, and inefficiencies within an organization. This can lead to process improvements and smoother workflow. Example: a logistics company analyzes its delivery routes and driver performance data. It finds that certain routes are causing delays. By optimizing these routes based on traffic patterns and delivery schedules, the company reduces delivery times and costs. 7. Risk management. Organizations can use data analytics to assess and mitigate risks, whether they are financial, operational, or market-related. By recognizing patterns that indicate potential issues, businesses can take preventive actions. Example: a bank uses data analytics to detect unusual transactions and flag potential fraudulent activities. This reduces financial losses and protects the organization from reputational damage. In conclusion, data analytics provides organizations with the insights necessary to make smarter decisions, optimize operations, reduce costs, improve customer experiences, and stay competitive. With its ability to unlock hidden insights from data, it empowers organizations to navigate complex challenges and make strategic moves based on evidence rather than assumptions. Next important question is: what is big data? Big data refers to large, complex sets of data that cannot be easily managed, processed, or analyzed using traditional data management tools or techniques. It is typically characterized by the three verses. 1. Volume, the sheer amount of data being generated, often measured in terabits or petabytes. 2. Velocity, the speed at which data is generated, processed, and analyzed. 3. Variety, the different types of data, including structured, organized in tables, semi-structured, XML, JSON, and unstructured data, text, images, videos. Big data often comes from a wide range of sources, such as sensors, social media, transaction records, and more, and it requires advanced tools and technologies like Hadoop, Spark, or machine learning algorithms to analyze and extract meaningful insights. Example of big data: e-commerce platforms. An e-commerce website like Amazon generates massive amounts of big data from millions of customers. Customer data, purchase history, browsing behavior, ratings, and reviews. Transactional data, sales transactions, payment methods, and shipping details. Social media data, customer feedback, and interactions on social media. Platforms. Real-time data, inventory updates, user search queries, and website clicks. By analyzing this big data, Amazon can personalize recommendations, offer tailored product suggestions based on user behavior, optimize supply chain, track inventory levels, and predict which products are likely to be in high demand, enhance customer experience, improve website design, promotions, and customer service based on user feedback. This ability to process and analyze large volumes of data in real time helps e-commerce companies stay competitive and responsive to customer needs. Next important question is data visualization. Data visualization is the process of representing data and information in a graphical or visual format. This makes it easier to understand patterns, trends, correlations, and insights within complex datasets. Instead of reviewing raw numbers or tables, data visualization uses charts, graphs, maps, and other visuals to help convey data in a way that is more intuitive and accessible. Conclusion. Data visualization transforms raw data into actionable insights by presenting it in a visually digestible form, allowing users to understand, analyze, and communicate information more effectively. Whether for business decision making, scientific research, or public awareness, it plays a crucial role in interpreting data. Next important question is data visualization tools. Data visualization tools are software applications that allow users to create visual representations of data, such as charts, graphs, and dashboards. These tools help in converting raw data into visual insights, making complex data more understandable and actionable. Below are some widely used data visualization tools, along with examples of how they are applied. 1. Tableau. Overview. Tableau is one of the most popular data visualization tools. It offers powerful features for creating interactive and shareable dashboards. It supports integration with various data sources such as SQL databases, cloud storage, and spreadsheets. Key features. Drag-and-drop interface for creating visualizations. Interactive dashboards. Real-time data analysis. Wide variety of charts, bar, line, scatter, etc. Example, a retail company can use Tableau to visualize sales, performance, product inventory, and customer demographics in an interactive dashboard. This helps managers make real-time decisions based on up-to-date data. 2. Power BI. Overview. Power BI, developed by Microsoft, is another popular business analytics tool that provides rich data visualization features. It integrates seamlessly with Microsoft products like Excel and Azure, making it especially useful for businesses already using Microsoft ecosystems. Key features. Easy-to-use interface with drag-and-drop options. Integration with multiple data sources, Excel, SQL Server, Google Analytics, etc. Customizable dashboards and reports. Advanced data modeling and analysis capabilities. Example, a financial services company can use Power BI to create visual reports and dashboards to track portfolio performance, analyze investment trends, and predict future market movements. 3. Google Data Studio. Overview. Google Data Studio is a free tool that allows users to create customizable and shareable reports and dashboards. It integrates easily with other Google services like Google Analytics, Google Ads, and BigQuery. Key features: free to use, integration with Google products and other data sources, interactive and dynamic reports, collaboration and sharing capabilities. Example, a digital marketing team can use Google Data Studio to create performance reports for a website, showing metrics like traffic sources, user behavior, and conversion rates. This allows for better optimization of marketing strategies. 4. ClickSense. Overview. ClickSense is a self-service data analytics and visualization tool that emphasizes interactive dashboards and data exploration. It provides in-depth analysis and associative exploration of data from different sources. Key features: associative data model for easy data exploration, high interactivity with drill downs and filtering, advanced analytics and reporting, mobile and cloud-based features. Example, a healthcare organization can use ClickSense to visualize patient health data, track performance metrics, and identify trends in disease outbreaks or treatment outcomes. 5. D3.js. Overview. D3.js is a JavaScript library for creating dynamic and interactive data visualizations in web browsers. Unlike other tools, D3.js requires coding knowledge but allows for extreme customization and flexibility in the creation of visuals. Key features: full control over the design and functionality of visualizations, ability to work with large datasets and produce complex visualizations, supports various types of charts, graphs, and even geographical maps. Example, a research organization can use D3.js to build complex visualizations such as interactive scatter plots, network graphs, or hierarchical visualizations to analyze scientific data. 6. Looker. Overview. Looker is a data platform that enables users to explore, analyze, and share real-time business insights. It is highly focused on providing modern business intelligence solutions and data exploration. Key features: data exploration and dashboards, integration with cloud-based databases like Google BigQuery, Snowflake, and Amazon Redshift, customizable reports and visualizations, collaboration tools. Example, an e-commerce business might use Looker to analyze customer purchase behavior, track product performance, and create real-time dashboards for sales teams to monitor KPIs. 7. Sisense. Overview. Sisense is a business intelligence tool that allows users to embed analytics into applications. It is known for its ability to handle complex datasets and provides interactive visualizations and dashboards. Key features: scalable and customizable dashboards, embedded analytics in applications, AI and machine learning powered insights, data integration from various sources. Example, a logistics company can use Sisense to track delivery performance across different regions, monitor shipping costs, and optimize their supply chain operations by analyzing historical and real-time data. 8. TIBCO Spotfire. Overview. TIBCO Spotfire is a powerful analytics and data visualization tool that provides in-depth analysis capabilities for large datasets. It is often used for business intelligence, predictive analytics, and real-time monitoring. Key features: predictive analytics and machine learning models, Advanced visualizations like heat maps, scatter plots, and geographical maps. Real-time data streaming and analytics. Integration with databases, cloud, and big data platforms. Example, a manufacturing company can use Spotfire to analyze machine data in real time, identify performance bottlenecks, and predict equipment failures before they occur. 9. Zoho Analytics. Overview. Zoho Analytics is a self-service business intelligence and analytics tool that helps businesses create reports and dashboards from a variety of data sources. Key features. Drag and drop interface for report creation. Wide variety of visualization types. Integration with Zoho apps, Google Analytics, and other third-party tools. Advanced data blending and reporting. Example, a small business might use Zoho Analytics to track sales, performance, customer acquisition, and financial data across different departments to make data-driven decisions. 10. Chart.js. Overview. Chart.js is a simple yet powerful open-source JavaScript library used for creating interactive charts and graphs on web applications. It's easy to use and integrates well with websites. Key features. Simple and lightweight for web applications. Supports various chart types like line, bar, radar, and donut charts. Interactive and animated visualizations. Customizable designs. Example, a tech startup might use Chart.js to visualize app performance. Metrics such as user engagement, session duration, and retention rates on their website. Conclusion. Each data visualization tool has its strengths, and the choice of tool depends on the specific needs of the user or organization. Tools like Tableau and Power BI are popular for their ease of use and wide applicability, while tools like D3.js offer flexibility for custom visualizations, and others like Sisense focus on embedding analytics within applications. The key is to select a tool that aligns with your data requirements, technical skills, and intended audience for the visuals. Next important question is statistical methods for summarizing data. Statistical methods for summarizing data involve techniques used to describe and summarize large amounts of data in a simpler, more understandable way. These methods allow us to gain insights into the data by identifying key characteristics and trends. Here are some common statistical methods for summarizing data. 1. Measures of central tendency. These measures describe the center or typical value of a dataset. Mean, arithmetic average. The mean is the sum of all the data points divided by the number of data points. Median. The median is the middle value of a data set when the data points are arranged in ascending or descending order. If there's an even number of data points, the median is the average of the two middle values. Mode. The mode is the value that occurs most frequently in the data set. 2. Measures of dispersion, spread. These measures describe how spread out or varied the data is. Range. The range is the difference between the maximum and minimum values in the dataset. Variance. Variance measures the average squared deviation of each data point from the mean. Standard deviation. The standard deviation is the square root of the variance and gives a sense of how much the data deviates from the mean in the same units as the data. 3. Percentiles and quartiles. These are values that divide the data into parts, and they give more insight into the distribution of the data. Percentiles. A percentile is a value below which a given percentage of observations fall. For example, the 50th percentile is the median where half the data lies below it. 4. Skewness and kurtosis. These measures describe the shape of the distribution of the data. Skewness measures the asymmetry of the data distribution. Positive skew means the data has a long tail on the right, while negative skew means the tail is on the left. 5. Data visualization. In addition to numerical summaries, data can be visualized using charts and graphs to identify patterns, trends, and outliers. Histograms, used for visualizing the distribution of numerical data. Box plots, used to show the spread and identify outliers. Bar and line charts, used to compare different categories or trends over time. Conclusion. Summarizing data statistically is essential for understanding large datasets and extracting meaningful insights. By using measures like the mean, median, variance, percentiles, and skewness, you can describe the key characteristics of the data, making it easier to interpret and analyze. These statistical methods are foundational for decision-making, research, and identifying patterns in the data. Next important question is measures of location. Measures of location are statistical methods used to identify the relative position or location of data points within a dataset. These measures help describe the central position or the distribution of the data, allowing us to understand where most of the data is concentrated. The main measures of location are percentiles, quartiles, and deciles. These measures are useful in summarizing large datasets, particularly in fields like economics, health, and education, where understanding the spread and central tendency of the data is essential. Summary of measures of location. Percentiles divide data into 100 equal parts and help locate the relative position of data points within the dataset. Quartiles divide the data into 4 equal parts, with Q1 25%, Q2 50%, and Q3 75% representing the key positions. Deciles divide data into 10 equal parts, offering more detailed location measures. Median is a special case of percentiles, 50th percentile, that separates the dataset into two halves. These measures are especially useful in understanding the distribution and spread of the data, identifying outliers, and comparing different datasets. Next important question is measures of variability. Measures of variability, also known as measures of dispersion, describe the extent to which data points in a dataset deviate from the central value, mean, median, or mode. These measures provide insights into the spread or consistency of the data. The more variable the data, the greater the spread of the values around the central tendency. Understanding variability is crucial because it helps assess the risk, uncertainty, and reliability of the data. Common measures of variability. 1. Range. 2. Variance. 3. Standard deviation. 4. Interquartile range, IQR. 5. Mean absolute deviation, MAD. 6. Coefficient of variation, CV. Summary of measures of variability. Range, the difference between the maximum and minimum values in a dataset. Variance, the average of the squared deviations from the mean, showing how spread out the data is. Standard deviation, the square root of the variance, providing a more interpretable measure of variability in the same units as the data. Interquartile range, IQR, the range of the middle 50% of the data. Robust two outliers. Mean absolute deviation, MAD, the average of the absolute differences from the mean, offering an intuitive measure of spread. Coefficient of variation, CV, a standardized measure of variability, allowing comparisons between datasets with different units or scales. These measures help to understand how much individual data points differ from the central value, providing valuable insights for analysis and decision-making. Next important question is measures of association. Measures of association are statistical tools used to assess the strength and direction of the relationship between two or more variables. These measures help determine whether and how variables are related to one another and can indicate the strength of the relationship. Measures of association are widely used in fields like statistics, social sciences, economics, and healthcare to draw inferences from data. Summary of measures of association. 1. Pearson's correlation coefficient, R, measures the strength and direction of the linear relationship between two continuous variables. 2. Spearman's rank correlation, Rho, measures the strength and direction of a monotonic relationship, useful for ordinal data or nonlinear relationships. 3. Kendall's tau, Tau measures the strength of the monotonic relationship between two variables, often used with ordinal data. 4. Chi-square test of independence assesses the association between two categorical variables. 5. Point biserial correlation measures the association between one continuous variable and one binary variable. 6. Kramer's V measures the strength of the association between two categorical variables. These measures help us understand the relationship between variables, enabling better analysis, decision-making, and prediction modeling in various fields like business, healthcare, and social sciences. Next important question is data modeling. Data modeling is the process of creating a conceptual representation of the data and its relationships within an information system. It involves designing the structure of data and how it is stored, processed, and used. Data modeling helps ensure that the data is consistent, accurate, and usable for various purposes, such as analysis, reporting, and decision-making. Benefits of data modeling. Data integrity ensures data consistency and accuracy by defining relationships and constraints. Efficiency optimizes the database design for faster querying and retrieval. Communication helps developers, business analysts, and stakeholders align on how data should be structured. Scalability provides a blueprint that supports growth and changes in data usage over time. Security allows for specifying constraints and rules that can enforce security measures, such as user access control. Conclusion. Data modeling is a critical step in the development of any database or information system. It provides a structured framework that ensures that data is stored, retrieved, and analyzed efficiently. By properly designing a data model, organizations can ensure that their data is well organized, easy to access, and reliable for decision-making. Next important question is Distribution fitting. Distribution fitting is the process of finding a statistical distribution that best matches a given dataset. The goal is to model the underlying distribution of the data in a way that can be used for further analysis, predictions, and decision making. In other words, distribution fitting allows us to identify which probability distribution describes the patterns and structure within the data. Conclusion. Distribution fitting is a powerful technique for modeling real-world data, helping to identify the underlying patterns and make predictions based on probabilistic models. By choosing an appropriate distribution and validating it using goodness of fit tests, you can effectively model data and make informed decisions in various fields, including finance, healthcare, engineering, and social sciences. Next important question is Karl-Pearson correlation technique. The Karl-Pearson correlation technique, also known as Pearson's correlation coefficient or Pearson's R, is a statistical method used to measure the strength and direction of the linear relationship between two continuous variables. It provides a quantitative assessment of how strongly two variables are related to each other. Formula for Pearson's correlation coefficient. The formula to calculate the Pearson correlation coefficient R is Assumptions of Pearson's correlation. Pearson's correlation technique assumes the following. 1. Linear relationship. The relationship between the variables is linear. Pearson's RR only measures linear correlations, not nonlinear ones. 2. Homogeneity of variance. The variance of the two variables should be similar, i.e., the data should not have extreme outliers. 3. Normal distribution. Pearson's correlation assumes that both variables are approximately normally distributed, though it can be applied to non-normally distributed data in practice. Practical applications of Pearson's correlation. 1. Finance. Analyzing the relationship between the returns of two different stocks to determine if they move together. Example, if two stocks have a high positive correlation, they may move in the same direction. 2. Marketing. Measuring the correlation between advertising spend and sales to assess whether increasing the marketing budget results in higher sales. 3. Health. Investigating the relationship between exercise and weight loss, or between smoking and lung disease. 4. Education. Studying the relationship between study hours and academic performance to understand how strongly they are related. Limitations of Pearson's correlation. 1. Linearity. Pearson's correlation only measures linear relationships. It does not capture nonlinear relationships, even if the two variables are related in a more complex way. 2. Sensitivity to outliers. Pearson's correlation can be heavily influenced by outliers. A few extreme data points can distort the correlation coefficient. 3. Causality. A high correlation does not imply causation. Just because two variables are correlated doesn't mean that one causes the other. Conclusion. The Karl-Pearson correlation technique is a valuable tool for assessing the strength and direction of a linear relationship between two continuous variables. It's widely used across various fields such as economics, healthcare, and social sciences to uncover patterns and relationships in data. However, it should be used with care, considering its assumptions and limitations, particularly when the relationship between the variables is nonlinear or when outliers are present. Next important question is simple and multiple regression. Regression analysis is a statistical technique used to model and analyze the relationship between variables. It helps in predicting the value of one variable based on the values of other variables. There are two main types of regression analysis: simple regression and multiple regression. 1. Simple regression, simple linear regression. Simple regression refers to a regression model that investigates the relationship between two variables, one independent variable, predictor, and one dependent variable, outcome. It assumes a linear relationship between the two variables. 2. Multiple regression. Multiple regression, also called multiple linear regression, is an extension of simple linear regression that models the relationship between two or more independent variables and a single dependent variable. This technique is used when we believe that the dependent variable is influenced by more than one factor. Conclusion: simple regression is used to model the relationship between two variables and is suitable when you have only one predictor. Multiple regression extends this by modeling the relationship between several independent variables and a dependent variable, allowing for more complex predictions. Both techniques are powerful tools in statistical modeling and predictive analytics, helping in various domains such as economics, business, healthcare, and more. Next important question is regression by the method of least squares. The method of least squares is a statistical technique used to find the best fitting line or curve to a dataset. The primary goal of this method is to minimize the sum of the squared differences, errors, between the observed values and the values predicted by the model. It is widely used in both simple linear regression and multiple regression to estimate the relationship between variables. Conclusion: the method of least squares is a foundational approach in regression analysis used to estimate the coefficients of the regression model by minimizing the sum of squared errors. Whether for simple linear regression, one independent variable, or multiple regression, multiple independent variables, least squares ensures that the best fitting line or plane is found to predict the dependent variable as accurately as possible. The method is widely used in fields such as economics, business, healthcare, and more for predictive modeling and data analysis. Next important question is building a good regression model. Building a good regression model involves several key steps that ensure the model is robust, accurate, and interpretable. Here are the best practices and guidelines to follow when building a regression model. Best practices for good regression models: avoid overfitting, regularization, cross-validation, and careful feature selection can help prevent overfitting. Handle multicollinearity if there's multicollinearity among predictors. Consider removing or combining highly correlated features or using regularization techniques. Ensure interpretability even if using advanced models like random forests or gradient boosting. Aim to ensure the model's behavior can be interpreted for better decision-making. Iterate. Building a good regression model is an iterative process. Regularly assess and refine the model as more data or new insights become available. By following these steps and practices, you can build robust and reliable regression models that perform well on unseen data and provide meaningful insights. Next important question is importance of assumptions in LDA. The assumptions of LDA play a crucial role in the performance and applicability of the algorithm. Here's why these assumptions matter. 1. Normality assumption. If the data is not normally distributed within classes, LDA may not produce reliable results. This is because the likelihood estimation of the parameters mean and covariance assumes a normal distribution. For instance, if the data is heavily skewed or has outliers, LDA's performance can degrade as it might misrepresent the data's distribution. 2. Same covariance assumption, homogeneity of variance. This assumption is perhaps the most critical for LDA. If the classes have different covariance matrices, i.e., they have different spreads or correlations between features, the optimal decision boundary may not be linear. LDA assumes that each class shares the same covariance structure, which helps it find linear decision boundaries. When this assumption is violated, the model may misclassify data and more flexible methods like quadratic discriminant analysis (QDA) may be needed. QDA allows each class to have its own covariance matrix, accommodating situations where LDA fails. 3. Linearity assumption. Since LDA creates linear decision boundaries, it's crucial that the true relationship between the features and the classes is approximately linear. If the data has complex, nonlinear relationships, LDA may fail to capture the underlying structure and may not perform as well. In such cases, nonlinear classifiers such as support vector machines, SVM, with kernel methods or random forests could be more effective. 4. Independence of features. When features are highly correlated, LDA may suffer from multicollinearity, leading to unreliable estimates of the means and covariance matrices. Correlated features can distort the projection of data onto the discriminants and affect the model's performance. Techniques like principal component analysis, PCA, or feature selection methods can be used to reduce multicollinearity before applying LDA. 5. Multivariate normality. LDA relies on the assumption of multivariate normality to estimate the class-wise means and covariances accurately. If the data violates this assumption, the class distributions may be misrepresented, leading to poor classification performance. However, in practice, LDA is often robust to mild violations of normality, especially when the sample size is large. In situations where the assumption is severely violated, alternative methods like QDA or non-parametric classifiers might be better suited. Summary. The assumptions of LDA, normality, equal covariance, linearity are important because they guide how LDA constructs its decision boundaries and how it processes data. Violations of these assumptions can lead to suboptimal or incorrect results. By understanding and checking these assumptions before using LDA, you can ensure that the method is appropriate for your data or consider using alternative methods if necessary. Next important question is one-way and two-way ANOVA analysis of variance. Analysis of variance, ANOVA, is a statistical method used to test if there are significant differences between the means of two or more groups. ANOVA helps in understanding how one or more factors, independent variables, affect a dependent variable. The two most common types of ANOVA are one-way ANOVA and two-way ANOVA, each used depending on the number of Independent variables involved in the analysis. One-way ANOVA. One-way ANOVA is used when you have one independent variable, factor, with more than two levels, groups, and want to determine if there is a statistically significant difference in the means of these groups. Key concepts. One independent variable, factor the variable that is being tested, to see how it affects the dependent variable. Multiple groups, levels. Each group represents a different level or category of the independent variable. Dependent variable, the outcome variable that you want to measure or predict. It should be continuous. Assumptions for one-way ANOVA. 1. Independence of observations. The data collected from different groups must be independent of each other. 2. Normality. The data in each group should be approximately normally distributed. 3. Homogeneity of variances. Homoscedasticity. The variance within each group should be roughly equal. This can be tested using Levin's test or Bartlett's test. Hypotheses. Null hypothesis. H. All group means are equal, no effect of the factor on the dependent variable. Alternative hypothesis. H. At least one group mean is different. Steps in one-way ANOVA. 1. Calculate the means for each group and the overall mean. 2. Calculate the between-group variance and the within-group variance. 3. Calculate the F-statistic using the formula above. 4. Determine the p-value using the F-distribution. If the p-value is less than the significance level, usually 0.05, reject the null hypothesis. Example. Suppose you want to test if 3 different teaching methods lead to different test scores. You have 3 groups of students, each taught by one method, and you want to compare the average test scores. Null hypothesis. H. The mean test scores are the same for all 3 groups. Alternative hypothesis. H. At least one group has a different mean test score. Two-way ANOVA. Two-way ANOVA is used when you have two independent variables, factors, and you want to examine their individual and combined effects on the dependent variable. It also allows you to explore the interaction between the two factors. Key concepts. Two independent variables, factors. These can be either categorical or continuous variables. The analysis investigates the main effects of both factors and their interaction effect. Dependent variable, the outcome variable that is continuous and is affected by the factors. Main effects, the individual effects of each factor, independent variable, on the dependent variable. Interaction effect, the combined effect of both factors, i.e., how one factor's effect on the dependent variable changes depending on the level of the other factor. Assumptions for two-way ANOVA. 1. Independence of observations, data from different groups and combinations of factors must be independent. 2. Normality, the data within each group combination should follow a normal distribution. 3. Homogeneity of variances, the variances within each group combination should be equal, tested using Levin's test. Steps in two-way ANOVA. 1. Calculate the means for each group combination, factor levels. 2. Calculate the main effect variances for each factor. 3. Calculate the interaction effect variance, if applicable. 4. Calculate the F-statistics for both main effects and the interaction effect. 5. Determine the p-values for each F-statistic. If the p-value for a main effect or interaction is less than the significance level, usually 0.05, reject. The null hypothesis. Conclusion. One-way ANOVA is useful when you have a single factor with multiple levels and you want to compare the means of these groups. Two-way ANOVA is appropriate when you have two factors and want to explore the individual and interaction effects of both factors on the dependent variable. Both methods allow you to determine whether differences between group means are statistically significant, but two-way ANOVA provides additional insights by considering interactions between factors. Next important question is scope of data mining. Data mining refers to the process of discovering patterns, trends, correlations, and useful insights from large datasets using various techniques from statistics, machine learning, artificial intelligence, and database management. Data mining involves analyzing data to extract hidden patterns that can provide valuable information for decision-making, predictions, and strategic planning. The scope of data mining is broad and touches many fields, industries, and disciplines. As data continues to grow exponentially in volume and complexity, the importance of data mining increases, enabling organizations to derive actionable insights from big data. Here is an overview of the key areas where data mining plays a significant role. 1. Business and marketing. Customer segmentation and profiling. Data mining can help businesses segment their customer base into distinct groups based on purchasing behavior, demographics, and other factors. This allows for targeted marketing strategies, personalized offers, and better customer relationship management. Market basket analysis, association rule mining. This technique identifies associations between different products that are frequently purchased together. For example, data mining helps retailers understand which products tend to be bought in combination, helping with product placement, bundling strategies, and cross-selling. Sales forecasting. Data mining can analyze historical sales data to predict future sales trends, enabling businesses to optimize inventory, staffing, and supply chain management. Churn prediction. By analyzing customer behavior, data mining can predict when customers are likely to leave, churn, and allow companies to implement retention strategies. Fraud detection. Data mining techniques such as anomaly detection are used to identify unusual patterns that could signify fraudulent activities in areas like credit card transactions, insurance claims, and online transactions. 2. Healthcare and medicine. Disease diagnosis and prognosis. Data mining can help medical professionals analyze patient data and detect patterns that correlate with specific diseases or conditions. It can also predict the likelihood of disease progression, helping with early diagnosis and personalized treatment plans. Medical image analysis. Techniques like image recognition and clustering are used in the analysis of medical images, X-rays, MRIs, CT scans to detect abnormalities such as tumors, fractures, or other medical conditions. Drug discovery and development. By analyzing large datasets of chemical compounds, clinical trial data, and molecular information data, mining can aid in the discovery of new drugs, predicting their efficacy, and identifying potential side effects. Genomics and biotechnology. Data mining plays a crucial role in genomics by analyzing gene sequences, protein structures, and genetic Data to identify patterns related to genetic disorders, diseases, and personalized treatments. 3. Finance and banking. Credit scoring. Financial institutions use data mining to assess the creditworthiness of individuals and businesses by analyzing historical data on their financial transactions, loan repayments, and other relevant factors. Risk management and portfolio optimization. Data mining helps banks and investors identify patterns in market behavior, enabling them to assess risks, predict market fluctuations, and optimize investment portfolios. Fraud detection and prevention. Data mining techniques like clustering and classification help detect unusual patterns of behavior in transaction data, which can indicate fraudulent activities such as identity theft, money laundering, or credit card fraud. Algorithmic trading. In the stock market, data mining algorithms analyze historical price data, social media, news, and other external factors to predict stock price movements and make real-time trading decisions. 4. Retail and e-commerce. Recommendation systems. Data mining powers recommendation engines like those on Amazon, Netflix, or Spotify, which suggest products, movies, or music to customers based on their past behavior or the behavior of similar users. Inventory management. By analyzing sales patterns, customer demand, and seasonality, data mining can help retailers optimize their inventory, reducing overstocking and understocking issues. Pricing strategy. Data mining techniques such as regression analysis and market basket analysis help retailers set dynamic prices, discount strategies, and promotional offers based on customer demand, competitor prices, and other factors. Customer behavior analysis. Retailers use data mining to understand customer preferences, shopping habits, and purchase patterns, which helps improve customer experience, loyalty programs, and targeted promotions. 5. Social media and sentiment analysis. Social media analytics. Data mining techniques are used to analyze data from social media platforms to track user sentiment, behavior, and engagement. This helps organizations understand public opinion, brand perception, and trends. Sentiment analysis. Data mining can analyze text data from social media posts, reviews, and comments to assess customer sentiments, positive, negative, or neutral, towards products, brands, or services. This is valuable for customer feedback, reputation management, and marketing campaigns. Trend detection. By analyzing large volumes of social media data, data mining can identify emerging trends, news stories, and topics of interest in real time, which is useful for public relations, marketing, and content creation. 6. Telecommunications. Customer retention. Telecom companies use data mining to analyze customer usage patterns and predict churn. By identifying at-risk customers, they can take proactive steps to retain them through targeted offers and services. Network optimization. Data mining is applied to network traffic data to optimize the performance of telecommunications networks, identify bottlenecks, and predict potential system failures. Fraud detection. Telecom providers use data mining to detect fraudulent activities such as unauthorized access, international call fraud, and identity theft. 7. Government and public sector. Crime analysis and prevention. Law enforcement agencies use data Mining to analyze crime data and predict where and when crimes are likely to occur. This allows them to allocate resources more effectively and prevent criminal activity. Tax evasion detection. Governments can use data mining to identify patterns in financial transactions that suggest tax evasion or illegal activities, enabling better enforcement of tax laws. Public policy and planning. Data mining helps governments analyze large datasets such as census data, public health data, and economic indicators to develop policies, allocate resources, and monitor societal trends. 8. Education. Student performance prediction. Data mining is used in educational institutions to analyze student data and predict their academic performance, helping to identify students who may need additional support. Curriculum development. By analyzing student learning patterns, feedback, and exam results, data mining helps improve teaching methods, customize learning materials, and design better curricula. Dropout prediction. Data mining can identify at-risk students who are likely to drop out, allowing schools to intervene early with counseling or other support mechanisms. 9. Manufacturing and supply chain. Predictive maintenance. By analyzing sensor data and historical maintenance records, data mining helps manufacturers predict when machinery is likely to fail, allowing for proactive maintenance and reducing downtime. Supply chain optimization. Data mining techniques are used to optimize supply chain processes such as inventory management, logistics, and procurement by identifying inefficiencies and predicting demand fluctuations. Quality control. Data mining can identify patterns in production data that lead to defects or quality issues, helping to improve product quality and reduce waste. 10. Energy and utilities. Energy consumption prediction. Data mining helps utility companies predict energy demand patterns and optimize resource distribution, leading to more efficient energy use and reduced costs. Smart grids. By analyzing data from smart meters and IoT devices, data mining can improve grid management, energy distribution, and fault detection in real time. Environmental monitoring. Data mining helps analyze environmental data such as air quality, water levels, and pollution to monitor and manage natural resources more effectively. Conclusion. The scope of data mining is vast and spans many industries, including business, healthcare, finance, marketing, retail, government, education, and more. As the volume of data continues to grow, the importance of data mining in extracting meaningful patterns, making predictions, and aiding decision-making will only increase. It enables organizations to gain a competitive edge, optimize operations, reduce costs, and enhance customer experiences, ultimately leading to more informed and efficient business practices. The applications of data mining are diverse and continually evolving, especially with the advent of big data, machine learning, and artificial intelligence. As technology advances, the scope of data mining will continue to expand, touching even more industries and fields of study. Next important question is data exploration and reduction. Data exploration and data reduction are essential steps in the data preprocessing pipeline. They help ensure that the data is ready for analysis, feature extraction, and modeling. Let's break down both concepts. 1. Data exploration. Data exploration, also known as exploratory data analysis or EDA, is the process of examining datasets to summarize their main characteristics, often visualizing them to uncover patterns, relationships, and anomalies. The goal is to understand the structure and distribution of the data before applying more complex analytical or modeling techniques. Why is data exploration important? It provides a deeper understanding of the data. It helps detect issues with the data, such as missing values, outliers, or incorrect data entries. It aids in formulating hypotheses and insights before applying more advanced techniques like machine learning models. 2. Data reduction. Data reduction is the process of reducing the complexity of the data without losing essential information. The main goal of data reduction is to make the dataset smaller and easier to process while retaining as much useful information as possible. Data reduction techniques are used to handle high-dimensional data or data that is large in size. Why is data reduction important? Efficiency. Large datasets can be computationally expensive and time-consuming to process. Data reduction makes it possible to perform analysis and modeling more efficiently by reducing the volume of data. Improved model performance. High-dimensional data can lead to overfitting or curves of dimensionality, where the model becomes too complex and performs poorly on new data. Reducing the number of features or dimensions can help improve model accuracy and generalization. Storage and memory. Data reduction helps to minimize the storage space required, making it easier to handle big data. It also reduces memory usage during model training and analysis. Data visualization. With fewer dimensions or features, visualizing the data becomes easier, making it possible to see patterns and trends more clearly. Conclusion. Both data exploration and data reduction are crucial steps in the data preparation process. Data exploration helps us understand the underlying patterns, relationships, and quality of the data before any analysis or modeling is performed. Data reduction allows us to efficiently handle large, complex datasets by simplifying them while maintaining the integrity and key information needed for analysis and predictive modeling. These techniques enable data scientists, analysts, and machine learning practitioners to work with cleaner, more manageable data, ultimately improving the quality of insights derived from the data and the performance of models built using that data. Next important question is different types of learning. In data mining, learning refers to the techniques used to extract meaningful patterns, relationships, and insights from large datasets. These methods are fundamental in understanding and making predictions based on data. Similar to machine learning, there are various types of learning approaches in data mining, and they are typically categorized as 1. Supervised learning, 2. Unsupervised learning, 3. Semi-supervised learning, 4. Reinforcement learning, 5. Deep learning or deep structured learning, 6. Association learning, 7. Evolutionary learning, 8. Active learning. Each of these learning types serves different purposes and is applied to various types of problems in data mining. Let's explore them in more detail. 1. Supervised learning. In supervised learning, The model is trained on labeled data where each input is paired with a corresponding target or label. The goal is to learn a mapping from input features to output labels, allowing the model to predict the label of new, unseen data. Key features. The dataset contains both input data and corresponding output labels. The model is trained using labeled data and makes predictions on future unseen data. Examples of algorithms. Decision trees. Naive Bayes. K-nearest neighbors, KNN. Support vector machines, SVM. Neural networks. Applications. Email spam detection, classification. Predicting customer churn, classification. Predicting future sales, regression. 2. Unsupervised learning. Unsupervised learning involves training a model on data that has no labels or targets. The goal is to uncover hidden structures or patterns in the data, such as grouping similar items or reducing dimensionality. Key features. There are no output labels associated with the input data. The algorithm learns the underlying structure of the data without predefined targets. Examples of algorithms. K-means clustering. Hierarchical clustering. DBS-CAN, density-based spatial clustering. Principal component analysis, PCA. Autoencoders, for dimensionality reduction. Applications. Market basket analysis, clustering customers based on purchasing patterns. Image compression, using dimensionality reduction to simplify large datasets. Anomaly detection, identifying outliers or fraud. Three. Semi-supervised learning. Semi-supervised learning combines both labeled and unlabeled data to improve learning accuracy, especially when labeled data is scarce and expensive to obtain. This approach is useful when you have a large amount of unlabeled data but a small amount of labeled data. Key features. A small portion of the dataset is labeled, and the majority is unlabeled. The algorithm uses both the labeled data and the unlabeled data to learn better patterns. Examples of algorithms. Semi-supervised support vector machines, S3VM. Label propagation algorithms. Applications. Image classification when only a few images are labeled. Text classification with only a limited number of labeled documents. Medical diagnosis where labeling data requires expert input. 4. Reinforcement learning. Reinforcement learning is a type of learning where an agent learns how to make decisions by interacting with an environment. The agent takes actions, receives feedback in the form of rewards or penalties, and learns to optimize its actions over time to maximize cumulative rewards. Key features. The agent learns through trial and error. The feedback received from the environment shapes the agent's decision making policy. Applications. Robotics, learning optimal actions in a dynamic environment. Game playing, example, AlphaGo, chess. Autonomous vehicles, learning to navigate and make decisions based on feedback. Financial portfolio management, learning to make investment decisions. 5. Deep learning, deep structured learning. Deep learning is a subset of machine learning that involves training artificial neural networks with many layers, hence deep. It is particularly powerful in handling large, complex datasets such as images, audio, and text. Key features. Uses multilayered neural networks for learning. Highly effective for large and unstructured data. Learns hierarchical representations of data. Applications. Image and video recognition. Natural language processing, example, chatbots, language translation. Speech recognition. Autonomous vehicles. 6. Association learning. Association learning involves finding associations or relationships between variables in large datasets. It is commonly used for market basket analysis and helps businesses discover which products are frequently purchased together. Key features. Focuses on identifying relationships between variables or items. Commonly used for discovering rules in transactional data. Applications. Market basket analysis, example, customers who buy bread may also buy butter. Cross-selling strategies in retail. Recommendation systems. 7. Evolutionary learning. Evolutionary learning refers to the application of evolutionary algorithms, which are inspired by biological evolution. These algorithms use processes like selection, mutation, and crossover to optimize solutions over generations. Key features. Inspired by natural evolution. Uses a population of solutions and evolves over time to find the best solution. Applications. Optimization problems where the search space is too large for traditional methods. Automated design processes, example, circuit design, software optimization. Machine learning feature selection. 8. Active learning. Active learning is a type of machine learning where the model can query or request additional labeled data points to improve its performance. It is particularly useful when labeled data is scarce or expensive. Key features. The model actively selects the most informative examples to learn from. Reduces the need for large labeled datasets by using a small but informative subset. Applications. Text classification in NLP where labeling requires human intervention. Medical image labeling where expert knowledge is needed to classify images. Active learning for building more efficient recommendation systems. Conclusion. In data mining, different types of learning enable businesses and analysts to extract valuable insights from data in various ways. Whether using supervised learning to predict future outcomes, unsupervised learning to uncover hidden patterns, or reinforcement learning for decision-making in dynamic environments, each type of learning serves a distinct role. Understanding these learning techniques allows organizations to apply the appropriate methods for their specific problems and optimize their decision-making processes. Next important question is classification accuracy and prediction accuracy. 1. Classification accuracy. Classification accuracy refers to the percentage of correct predictions made by a classification model. It is a measure of how well the model performs in terms of predicting the correct class for a given observation. Formula for classification accuracy. When to use. Classification accuracy is typically used when the classes are balanced, i.e., each class has a similar number of instances. It is a good metric when you are interested in the overall performance of a model without focusing too much on individual class performance. Limitations. It does not provide insight into how well the model performs on each class, especially in imbalanced datasets. It is not sensitive to the type of error, whether a false positive or false negative occurs. 2. Prediction accuracy. Prediction accuracy is a more general term used to evaluate the performance of any predictive model, including regression models. It can refer to the percentage of accurate predictions made by a model for both classification tasks, when the output is a category, and regression tasks, when the output is a continuous value. Formula for prediction accuracy in classification. For classification, prediction accuracy is the same as classification accuracy. Example, regression. In a regression task predicting house prices, the model might predict values that are close to the actual prices. If the R-squared value is 0.85, it means 85% of the variance in the house prices can be explained by the model's predictions. When to use? Prediction accuracy can be used in both classification and regression tasks. In classification, it refers to how well the model correctly classifies instances. In regression, it refers to how well the model predicts continuous values, often quantified using R superscript 2, May, MSE, etc. Limitations. For regression models, prediction accuracy is typically associated with the level of error, not simply the percentage of correct predictions. In classification, prediction accuracy can be misleading in the case of imbalanced classes or when the costs of different types of errors, false positives versus false negatives, vary. Conclusion. Classification accuracy is a straightforward metric for evaluating classification models by measuring the percentage of correctly predicted instances. Prediction accuracy, while similar in some contexts, like classification, is a broader term that can apply to both classification and regression tasks. For classification, it is essentially the same as classification accuracy, but for regression, it typically involves using error metrics like R superscript 2, May, or MSE to assess how well the model's predictions align with the actual values. In either case, it's important to choose the correct metric based on the type of problem, classification versus regression, and consider other evaluation metrics, especially in cases of imbalanced data or specific business requirements. Example, minimizing false positives or false negatives. Next important question is K-nearest neighbors, KNN. K-nearest neighbors, KNN, is a simple, versatile, and widely used supervised learning algorithm for both classification and regression tasks. KNN makes predictions based on the closest data points, neighbors, in the training dataset. It doesn't require a training phase in the traditional sense, as it directly makes predictions using the available data. Advantages of KNN. 1. Simple and easy to understand. KNN is intuitive and easy to implement, making it a great starting point for machine learning tasks. 2. No model training. There is no explicit training phase. The algorithm works by storing the entire dataset and making predictions based on that data. 3. Flexible. KNN can be used for both classification and regression tasks. 4. Non-parametric. KNN does not assume any specific distribution of the data, which makes it versatile for various types of datasets. Disadvantages of KNN. 1. Computationally expensive, as the algorithm needs to calculate the distance between the query point and all points in the dataset. It can be computationally expensive, especially with large datasets. 2. Sensitive to irrelevant features. The performance of KNN can degrade if there are irrelevant or redundant features in the data. 3. Curves of dimensionality. as the number of features dimensions increases, the distance between data points becomes less meaningful, which can affect the performance of the model. Dimensionality reduction. Techniques like PCA may be needed to address this. 4. Choice of K. Selecting the right value for K is crucial. A poor choice can lead to overfitting or underfitting. 5. Memory intensive. Since the entire dataset needs to be stored for making predictions, KNN requires a large amount of memory for large datasets. Applications of KNN. Classification tasks. Image recognition, identifying objects in images by comparing the query image to labeled examples. Medical diagnosis, classifying diseases based on symptoms or medical imaging data. Spam detection, identifying spam or non-spam emails based on features of the email content. Regression tasks. Predicting house prices, predicting the price of a house based on features such as size, location, etc., by averaging the prices of similar houses. Stock price prediction, predicting the future price of stocks based on historical trends. Conclusion. K-Nearest Neighbors, KNN, is a simple, powerful, and intuitive algorithm used for both classification and regression tasks. While it is easy to understand and apply, it does come with some challenges, such as high computational costs and sensitivity to feature selection. Despite these limitations, KNN remains a popular choice for many machine learning tasks, especially in cases where interpretability and simplicity are important. Next important question is classification and regression trees, CART. Classification and regression trees, CART, are popular decision tree algorithms used in machine learning for classification and regression tasks. CART builds binary trees by splitting data into subsets based on feature values, and the resulting tree is used to make predictions for new instances. 1. Classification trees, CART for classification. In classification tasks, CART is used to predict the class label of a data point based on input features. The algorithm builds a binary decision tree where each internal node represents a decision based on a feature and the leaves represent the predicted class labels. 2. Regression trees, CART for regression. In regression tasks, CART is used to predict a continuous value rather than a class label. The tree is built similarly to classification trees, but at the leaf nodes. Instead of assigning a class label, the predicted value is the average of the target values in that region of the feature space. Advantages of CART. 1. Easy to understand. The resulting model is interpretable and can be visualized as a decision tree. 2. Handles both classification and regression. CART can be applied to both classification and regression problems. 3. Nonlinear relationships. Decision trees can capture nonlinear relationships between features and target variables. 4. No need for feature scaling. Since CART is based on splitting data based on feature thresholds, there is no need to normalize or scale the features. 5. Handles missing values. CART can handle missing values in the dataset by using surrogate splits. Disadvantages of CART. Overfitting. CART models are prone to overfitting, especially with deep trees. Pruning or limiting the tree depth can help mitigate this. Instability. Small changes in the data can result in large changes in the structure of the tree. Biased towards features with more categories if one feature has many possible values, example, categorical variables with many levels, the tree may bias toward splits based on that feature. Not smooth, the predictions of a decision tree are piecewise constant, so the model may not capture smooth relationships well. Applications of CART. Medical diagnosis, predicting the presence of a disease based on various features, example, age, symptoms, test results. Credit scoring, assessing the likelihood of a borrower defaulting on a loan based on financial data. Customer segmentation, segmenting customers based on purchasing behavior for targeted marketing. Predicting house prices, estimating the price of a house based on features like size, location, number of rooms, etc. Conclusion. Classification and regression trees, CART, are fundamental machine learning techniques used for both classification and regression tasks. They offer simple, interpretable models that can capture complex relationships between features and target variables. However, they are prone to overfitting and can be unstable, requiring careful tuning and pruning to achieve optimal performance. Despite these challenges, CART remains a powerful tool for predictive modeling, particularly when interpretability and simplicity are important. Next important question is random number generation, RNG. Random number generation refers to the process of generating a sequence of numbers or symbols that cannot be reasonably predicted better than by random chance. Random numbers are essential in many areas of computing and data analysis, such as simulations, cryptography, machine learning, and statistical sampling. There are two types of random number generators. 1. True random number generators, TRNGs. 2. Pseudo-random number generators, PRNGs. 1. True random number generators, TRNGs. A true random number generator, TRNG, generates random numbers based on a physical source of entropy, such as noise, radioactive decay, or atmospheric noise. The key characteristic of TRNGs is that the numbers they produce are entirely unpredictable because they are derived from a non-deterministic process. Use cases. Cryptographic applications, where unpredictability is crucial for securing data. Scientific simulations that require true randomness for accurate modeling. Advantages. Generates true randomness. Useful for applications that require high security, example, cryptography. Disadvantages. Slower and more expensive than PRNGs. Hardware dependent, requiring physical devices or sensors. Limited availability for general-purpose computing. 2. Pseudo-random number generators, PRNGs. A pseudo-random number generator, PRNG, uses mathematical algorithms to generate a sequence of numbers that appear random but are completely determined by an initial starting point called a seed. Although the numbers appear random, they are actually generated by deterministic processes. Advantages. Fast and efficient. Can generate large sequences of random numbers quickly. Works without any special hardware, software-based. Disadvantages. Numbers are not truly random, they are deterministic and can be reproduced if the seed is known. Not suitable for cryptographic applications unless a CSPRNG is used. Conclusion. Random number generation is an essential concept in many areas of computing, from simulations to cryptography. While true random number Generators, PRNGs, provide the highest level of randomness, pseudo. Random number generators, PRNGs, are widely used due to their efficiency and speed. PRNGs are often sufficient for non-security critical applications, while CSPRNGs are necessary for cryptographic use cases requiring high security. Understanding the differences and applications of these generators is key to using them effectively in various fields. Next important question is Monte Carlo simulation. Monte Carlo simulation is a computational technique used to understand the impact of uncertainty and variability in mathematical models and systems. It relies on random sampling to obtain numerical results and is often used when it is difficult or impossible to solve problems analytically. Monte Carlo simulations are named after the famous Monte Carlo casino in Monaco because of the element of chance, randomness, involved in the simulations, which is analogous to the randomness found in gambling. How Monte Carlo simulation works. 1. Define the problem. Identify the problem that involves uncertainty and requires simulation. Example, predicting the future value of a financial asset, estimating the area under a curve, etc. 2. Identify variables. With uncertainty, identify the variables in the problem that have uncertainty. These are the variables you will generate random samples for. 3. Generate random inputs for each uncertain variable randomly. Generate a value according to its probability distribution. Example, uniform, normal, binomial. These inputs should represent the potential range of values the variable can take. 4. Run the simulation. Use the randomly generated values for each uncertain variable to compute the result of the model. This might involve running a complex model or performing numerical calculations. 5. Repeat the process. Repeat the simulation many times, each time generating new random samples. This builds up a distribution of possible outcomes. 6. Analyze the results. After a large number of simulations, analyze the results. You can calculate various statistics such as the mean, variance, confidence intervals, etc. to understand the range of possible outcomes and the probability of different scenarios. Advantages of Monte Carlo simulation. 1. Versatility can be applied to a wide range of problems in various fields, such as finance, physics, engineering, and more. 2. Handles complex problems, can be used to solve problems that are too complex to solve analytically, particularly those involving uncertainty. 3. Easy to implement. It is relatively easy to implement with modern computational tools and can be scaled up to simulate large systems. Disadvantages of Monte Carlo simulation. 1. Computationally intensive. Requires a large number of random samples to obtain accurate results, which can be computationally expensive. 2. Accuracy depends on sampling. The accuracy of the results depends on the number of simulations run. More simulations usually lead to more accurate results, but at the cost of higher computational resources. 3. Not always suitable for deterministic problems. For problems that are entirely deterministic, no uncertainty or randomness, Monte Carlo simulations may be unnecessary. Conclusion. Monte Carlo simulation is a powerful technique for solving problems that involve uncertainty or variability. It provides insights into a system's behavior by simulating various scenarios based on random sampling, helping to model complex systems, assess risks, and make informed decisions. Although it is computationally intensive, it is widely used in fields such as finance, engineering, and scientific research due to its flexibility and ease of implementation. Next important question is, what-if analysis? What-if analysis is a decision-making technique used to predict the possible outcomes of different scenarios by manipulating input variables in a model. It helps individuals and organizations explore the effects of different assumptions or decisions before they are made. The process involves changing the values of one or more variables to see how those changes affect the outcome. This technique is commonly used in business, finance, engineering, and other fields where decisions depend on uncertain variables, allowing users to test various scenarios without actually implementing them. Benefits of what-if analysis. 1. Informed decision-making. By testing different assumptions and scenarios, decision-makers can understand the range of possible outcomes and make more informed choices. 2. Risk mitigation. What-if analysis helps in identifying risks by evaluating the worst-case scenarios and preparing contingency plans. 3. Optimized performance. Businesses can find the optimal combinations of variables to maximize profits, minimize costs, or achieve other business objectives. 4. Predictive power. It provides insights into how certain variables influence outcomes, helping anticipate the results of decisions before they are made. Limitations of what-if analysis. 1. Limited to assumptions. The accuracy of the analysis is limited by the quality and relevance of the assumptions. If the assumptions are wrong, the conclusions will also be inaccurate. 2. Complexity in multidimensional problems. As the number of variables increases, what-if analysis becomes increasingly difficult to manage and interpret, especially in complex systems. 3. Requires expertise. Effective use of what-if analysis tools often requires expertise in both the modeling process and the interpretation of results. 4. Computational cost. In some cases, example, Monte Carlo simulations, running a large number of simulations or scenario combinations can be computationally expensive and time-consuming. Conclusion. What-if analysis is a valuable decision-making tool that helps businesses and individuals explore different scenarios and understand the potential impact of changes in variables. By providing insights into possible outcomes, it aids in risk management, performance optimization, and forecasting. Whether used for simple decision-making or complex simulations, it helps mitigate uncertainty and supports more informed, strategic decisions. Next important question is advantages and disadvantages of simulation. Simulation is a powerful tool used across various fields, such as engineering, business, healthcare, finance, and operations, to model the behavior of systems and assess how changes in different variables impact outcomes. It involves creating a virtual model that mimics real-world processes and using that model to experiment with different scenarios or predict future events. However, like any methodology, simulation has both advantages and disadvantages. Below are some of the key benefits and drawbacks associated with simulation. Advantages of simulation. 1. Risk-free experimentation. Safe testing environment. Simulation allows experimentation with different scenarios without the real-world consequences or risks. 4. Example, businesses can test marketing strategies or assess financial investments without actual financial loss. Avoiding dangerous or costly trials in fields like healthcare, engineering, and manufacturing, simulations can be used to test designs, processes, or equipment without the risk of real-world harm or expensive failures. 2. Handling complexity. Modeling complex systems. Some systems are too complex or chaotic to be analyzed analytically. Simulation allows for the modeling of systems with multiple interacting variables, example, supply chain, traffic flow, or financial systems. Nonlinear systems, in cases where variables interact in nonlinear ways, simulations provide a way to predict outcomes that may be difficult or impossible to derive using traditional mathematical models. 3. Cost-effective. Cost savings. Before investing in new equipment, procedures, or technologies, simulation can help optimize designs and strategies, saving money by identifying inefficiencies early in the process. Avoiding prototype costs. In product development, simulation can be used to test various design prototypes virtually, reducing the need for physical prototypes that are costly and time-consuming to create. 4. Improved decision-making. Scenario testing. Simulation helps decision-makers test a wide variety of what-if scenarios, providing a clearer understanding of the possible outcomes under different conditions. Predictive power. By running simulations, users can estimate future outcomes or trends based on different inputs or decisions, aiding in forecasting and strategic planning. 5. Time saving. Efficient experimentation. Running simulations is often faster than running physical experiments. This allows for quick iterations and testing of multiple variables or scenarios in a short time. Real-time adjustments. Simulations can be adjusted in real time as new data becomes available, making it possible to monitor changes continuously and optimize systems on the fly. 6. Optimization. Resource allocation. Simulations can help identify the best allocation of resources, whether it's human resources, financial assets, or raw materials, by optimizing system parameters. Production and logistics optimization. In manufacturing and supply chain management, simulations can help optimize production schedules, inventory levels, and distribution networks. 7. Visual representation. Graphical insights. Many simulation tools come with powerful visualization features that allow users to visually analyze system behavior, making it easier to communicate results and insights to stakeholders. Data representation. Graphs, charts, and heat maps can effectively represent complex data, helping users understand patterns and trends. 8. Testing under uncertainty. Stochastic modeling. Simulations allow for testing systems under conditions of uncertainty. Random variables, such as demand or stock market prices, can be modeled to simulate real-world variability, providing more robust decision-making insights. Disadvantages of simulation. 1. Complexity in model development. Building accurate models. Creating a valid and accurate simulation model requires a thorough understanding of the system being modeled. Incorrect assumptions, oversimplified models, or poor data can lead to inaccurate results. Time-consuming setup. Developing a simulation model from scratch, especially for complex systems, can be time-consuming and require significant expertise in both the domain and the modeling. Process. 2. Data requirements. Data dependency. The accuracy of a simulation heavily relies on the quality and availability of data. Incomplete or inaccurate data can lead to misleading results. Gathering reliable data may be challenging in some industries or for certain systems. Data collection challenges. In some cases, real-world data might not be available or may be too expensive or difficult to obtain. 3. High computational costs. Resource-intensive. Some simulations, especially those involving complex systems or running large numbers of iterations, example, Monte Carlo simulations, require significant computational power and resources. Hardware and software needs. Running sophisticated simulations may require expensive hardware, specialized software, and high-level computing resources, which could be a barrier for some users. 4. Oversimplification. Model assumptions. Every simulation model is a simplification of the real-world system, and this simplification may omit crucial details or interactions that impact results. Depending on the complexity of the system, the model may not capture all the nuances, leading to potential inaccuracies. Risk of misleading results. If assumptions or simplifications are not well thought out, simulations can yield results that are far from reality. Users may mistakenly treat simulation outcomes as exact predictions rather than estimates based on simplified models. 5. Lack of real-world feedback. Simulated versus real-world conditions. Even though simulations are designed to mimic reality, they cannot always account for the full range of unpredictable, real-world factors, example, human behavior, external disruptions. Thus, simulation results should always be viewed in conjunction with real-world experimentation or feedback. Difficulties in calibration. It can be difficult to fine-tune and calibrate models so that they accurately reflect real-world behavior. Small errors in calibration can lead to significant discrepancies in results. 6. Dependence on user expertise. Need for expertise. Effective use of simulation tools requires expertise both in the underlying system being modeled and in the simulation software itself. Users need to understand the system's dynamics and how to interpret the results of a simulation properly. Interpretation challenges. The output of a simulation often needs to be interpreted carefully. Without a clear understanding of the model's assumptions and limitations, users may draw incorrect conclusions from the results. 7. Risk of over-reliance on simulations. False confidence. Decision-makers may place too much trust in simulation results, assuming that the model is always accurate and reflective of real-world scenarios. This over-reliance can be dangerous if the model is based on incorrect assumptions or incomplete data. Neglecting other approaches, focusing solely on simulation may cause users to neglect other valuable decision-making tools or real-world validation methods. 8. Potential ethical issues. Unintended consequences. Some simulations might not fully account for the ethical implications of certain scenarios. For example, using simulations in healthcare or social systems could potentially result in biased or harmful outcomes if not carefully managed. Impact on employment in industries like manufacturing or service. Simulations used for automation and optimization may lead to job displacement if workers are not retrained to perform new tasks. When to use simulation? Despite its drawbacks, simulation remains an essential tool in many industries. It is particularly useful when the system being modeled is too complex for analytical solutions. Real-world experimentation is too expensive, dangerous, or impractical. Decision-making involves uncertainty, such as forecasting, risk analysis, or predicting outcomes based on random variables. Optimization of resources, scheduling, or production is required in dynamic systems. Businesses need to test multiple what-if scenarios to evaluate different strategies or decisions. Conclusion: simulation is an incredibly valuable tool for understanding complex systems, experimenting with various scenarios, and optimizing processes. However, it comes with some limitations, such as the need for accurate data, computational resources, and expert knowledge. Despite these disadvantages, when used appropriately, simulation can lead to better decision-making, reduced risk, cost savings, and improved system performance. Like any tool, its effectiveness depends on how it is used and how well the model reflects reality. Next important question is decision tree. A decision tree is a powerful and interpretable machine learning model that can be used for both classification and regression tasks. It works by recursively splitting the dataset into subsets based on feature values in such a way that the resulting subgroups are as pure as possible with respect to the target variable. Here's an analysis of decision trees, covering their structure, working, strengths, weaknesses, and use cases. Structure of a decision tree. A decision tree consists of the following components. Root node. This is the topmost node and represents the entire dataset. It is the first decision point where the dataset is split based on a specific feature. Internal nodes. These are nodes where further splits are made based on feature values. Each internal node represents a decision rule. Leaf nodes. These are the terminal nodes that represent the final decision, the class label for classification or the predicted value for regression. Edges branches. These represent the outcomes of a decision or test at each node and connect nodes together. Advantages of decision trees. Interpretability. Decision trees are easy to understand and interpret. You can visualize the tree and follow the decisions made at each node. Nonlinear relationships. Decision trees can handle nonlinear relationships between features and target variables. Handles both numerical and categorical data. They can be applied to both types of data without much preprocessing. No need for feature scaling, unlike algorithms like K-nearest neighbors, KNN, or support vector machines, SVM. Decision trees do not require feature scaling. Handling missing values. Decision trees can handle missing data well through surrogate splits. Disadvantages of decision trees. Overfitting. Decision trees tend to overfit, especially with deep trees. This means they may perform well on training data but poorly on unseen data. Instability. Small changes in the data can result in completely different tree structures. Bias toward features with more levels. Features with many categories may dominate the decision-making process if not properly controlled. Computational complexity. For very large datasets, the training time can increase significantly, especially if the tree grows very deep. Conclusion. Decision trees are a versatile and widely used tool in machine learning. They provide a straightforward approach to both classification and regression problems and offer great interpretability. However, they can suffer from overfitting and instability, so techniques like pruning and ensemble learning are often used to improve their performance. Despite these drawbacks, decision trees remain popular due to their simplicity, flexibility, and ability to handle a wide variety of tasks.